Example 1. Is this the reasoning? So let's read scenario A, part A, and then we're going to decide on inductive or deductive reasoning. So think about what we just talked about, the definition of them.
Okay.
And I'll let you process that. So the first part, Josh knows that brand X computers cost less than brand Y computers. All other brands that Josh knows of cost less than brand X. Josh reasons that brand Y costs more than all other brands.
Okay. Well, the first thing that I noticed is, okay, he knows that brand X costs less than brand Y. And up at the top. Sorry.
Oh, yeah, up here. Sorry.
That's all right.
I saw Josh knows. So
Yes.
he knows brand X computers cost less than brand Y.
Yeah, but then the next thing you underline, that all other brands that he knows of. So this isn't necessarily every brand. These are only the brands that he knows.
And he may know of some, but there might be some out there he's unaware of.
Sure.
Okay.
Okay. So yes, he has some data, but he doesn't necessarily have all of the data to use. I'm thinking it's more inductive, not deductive, because he is using basically like the patterns or the previous examples to make a conjecture. This sounds like a conjecture to me because he's, going off of these patterns that he's noticed before to make this statement. Exactly. It's not all fact.
And it seems like there's a little bit of gap. You can kind of question it because of the fact that he says all other brands he knows of. I like that. That's kind of that sentence is the one that I think kind of throws it out there that it's inductive.
Yeah. Okay.
Good job. All right, so part B says Josh knows that brand X computers cost less than brand Y computers. So it starts the same way as part A. So he knows this. He also knows that brand Y computers cost less than brand Z. Josh reasons that brand X costs less than brand Z.
Okay. Well, this one, I'm going to just look at the words knows. He knows brand X computers cost less than brand Y. He also knows that brand Y costs less than brand Z. You know what this almost sounds like to me? This sounds almost like the law of syllogism idea.
Yeah, it does.
Where you have one hypothesis with one conclusion, and then that same conclusion from one is the hypothesis of the next one. Mm-hmm. There's no guesswork here. Mm-hmm. He knows all these things. So this is deductive reasoning. This is using we're coming up with a logical argument. Mm-hmm. There's no doubt about it.
And whenever I read that, and his reason, his last sentence in this, when he says Josh reasons that brand X costs less than brand Z, based on what he knows from the two prior sentences, that would be a logical argument.
Yeah.
Very no gaps, very conclusive.
Very straightforward.
Very straightforward.
Okay.
So that's the difference between those two.
That makes sense. All right. This one, we're going to determine if the argument is valid. Okay, so this is taking this a step further.
Okay.
Decide if this argument is valid. Sarah knows, for A, it says, Sarah knows that all sophomores take a driver's education in her school. Hank is a sophomore at Sarah's school, so Hank takes driver's education.
All right, so the fact that Sarah, at her school, all sophomores are taking driver's ed and Hank's a sophomore,
right?
Well, then he would have to take driver's ed. So I would say that's a valid argument.
Okay, and you're right. Now, think about that law of detachment that we talked about just a little bit ago, because we said we know that all sophomores take driver's education. There's our true statement.
Yeah.
So if the first part is true, if Hank is a sophomore, then yes, he is going to take driver's education. That's that whole idea of the law of detachment.
Well, that kind of clears up that law a little bit, even though that's not in if-then form, as in the law itself. That's okay.
Right.
You can still look at the
You could make a
pieces.
conditional statement out of that.
Yes, you can look at the hypothesis conclusion. Awesome.
Okay, now B says if two angles form a linear pair, then they are supplementary. Angle A and angle B are supplementary, so angle A and angle B form a linear pair.
Right. That first sentence, that if-then, that conditional, I know, because we talked about this. We know that a linear pair does mean supplementary. So that is a true statement.
Okay, so this part right here is true.
Yes. But then you'll notice the next statement, they're talking about, or in the next piece, they're talking about just two angles being supplementary. And then they're concluding, well, then that has to mean that they're going to be a linear pair. Well, the issue with that is supplementary angles don't have to be a linear pair. Like, they can be non-adjacent. As long as they add up to 180, they don't have to actually be a linear pair. So I would say that's an invalid argument because you could come up with a counterexample.
Exactly. And thinking about that law of detachment, we said if you're starting off with a true conditional statement, if the hypothesis is true, that implies that the conclusion will also be true. But notice that we have a true conditional statement, but it's not the hypothesis that they tell us. They're giving us the what?
The conclusion.
Yeah.
Okay.
So I can't flip it around.
Okay.
It would have to be a biconditional to know that.
Yeah.
Okay.
Example 3. State whether any conclusions can be made using the true statement, given that x equals 3. All right, so first and foremost, they're telling you that the whole statement, this whole thing is true.
Okay.
And they're saying x is going to be 3. So they could give you another value, but this is the value they're giving as x. Now, going back to the previous example, law of detachment. I think Ms. Hochgravy did a great job explaining with those examples. Law of detachment states that this whole thing is true, but what else has to be true?
If the hypothesis is true, then the conclusion will be true.
Okay, so we need to see first if this is true before we can make a conclusion about this.
So let's take a look.
Okay, so what we're going to do is we're going to use that value of x, and what do you think we're going to do with it?
I'm guessing we're going to substitute it in. Just use some basic algebra.
So let's put it in here. So it's going to be 2 times 3 plus 3 is
9.
And then I'm going to see. I'm not sure. This is what we're questioning.
Okay.
Then 4 times 3 is
12.
And then we're going to see, does that or is that less than, or 5 times 3, which is
15.
So is this part true?
Yeah, sure. 9 is less than 12, which is less than 15.
Okay, so we have the whole conditional statement true, which was provided. They told you that. We found that the hypothesis is true. So what does that mean?
So that means the conclusion has to be true as well. But I'm guessing since there is an x up there, that means I need to substitute that in as well.
So then my conclusion, I'm going to say my conclusion
is that y would be less than or equal to 3.
Excellent job. All right, let's try another one. It says if x plus 3 equals 10, then y equals x. So again, same as the last one.
Okay, so we know that's true.
This whole thing is true. This whole thing is true. Our question is this part true or not? That's our question.
Okay, so if that part's true, then the conclusion is true again. But if not, then what?
Then that's a good question. Let's see. Let's find out.
Okay, well, let's find out if it is.
Let's find out first. We'll get there. So I'm going to do that. What with that x? I'm going to put 3 in there. So 3 plus 3 is
6.
Well,
right, and that's what I was kind of noticing.
That's
not.
So you saw that. And in the math, we're not trying to trick you guys with the math. So so what we're finding out, if the whole conditional statement is false, or whole conditional statement is true, but the hypothesis is not true,
then I'm guessing the conclusion would not be true either.
Exactly. So that means, what can we conclude? What's going to be our conclusion?
Can we say that y does not equal 3?
Yeah, you're good. So y cannot equal 3 in this case. Whoops.
Okay.
Because basically y cannot equal x, and it won't work out.
Okay. All right, so for this next example, we're going to use the law of syllogism. We're going to write some new conditional statements that can be made from the following true statements. These are all true statements, using the law of syllogism. This is where I want to combine statements together, okay? This is where we looked at our examples that said if we know that P implies Q is true and we know that Q implies R is true, then we can state that P implies R.
Okay.
Remember doing that?
Yeah, but now this time around,
get rid of those for just a second, just that way we can have some room to write.
But this time around, we're actually using actual words, sentences, not the variables, the symbolic notation. Stuff like that. Okay, I'm going to look through the statements, and I'm looking at the first 2. I'm noticing something.
What do you notice?
It says, the first one says, if it is lightning outside, then the football game will be canceled. Where the second one starts, if the football game gets canceled, then the players will not be on the field. So the fact that they have, the first one ends where the second one starts, I can create a new conditional statement. That's
Absolutely.
True.
Which, do you remember, we basically don't see that cue in that new statement anymore. So we can think about
getting rid of that. And then my new statement would be, if it is lightning outside, then the players will not be in the field. So I use the first 2 statements to combine, basically, to make another true statement.
Perfect. Okay, do you see another one we can make?
I think 3 and 4 can do the same thing, and exactly in that order. So if you know the players are not on the field, then the coaches will not be on the field. Well, if the coaches aren't on the field, notice kind of I just repeated myself, then the team cannot practice. So I'm going to come up with the new statement. If the players are not on the field, then the team cannot practice.
Awesome.
Now,
look at
question.
Yeah.
So the 2 that I just came up with, those are true statements, right?
Those are true statements.
So if those are both true, and the only reason I'm questioning this is because I noticed this one ends the same way as the next one begins. So could I come up with a new statement now?
Absolutely. What would it be?
It would say, if it is lightning outside, then the team cannot practice.
And that is another true statement. So you can use law of syllogism to put 2 statements together. But once you've put 2 statements together, you've made a new conditional statement.
And you can use that with something else. It's basically any 2 conditional statements that have something in common can create a new one.
Exactly.
And you can, it's one thing I noticed when I look back at it, it's kind of like number 1 and number 4 combined because of the fact that 2 and 3 have something in common with those.
Exactly.
Example 5 is the same directions as example 4, but we did a little bit changing of things. And what you're going to notice is that the last one we kind of try to make it a little bit easier for you just to kind of see the order. It's not going to be in order always.
Okay.
So when you start reading it, some of them aren't that way, but if you look at the statements 3 and 4 in that order, notice where this one ends, it doesn't begin there. So we can't just say, okay, well, 2 and 3 go together, 4 and 5. So we might have to do some rearranging of stuff, and that's totally cool with me. All right, so our goal is to come up with some conditional statements from these true statements. So we need to find 2 conditional statements where one ends, the other one begins. And I can move these around if you need me to.
Okay, well, the first 2 really already go together.
Oh.
So we could make a statement that says, because they both have that 110. And again, it's one conclusion and the other hypothesis. So I'm going to
get rid of that and get rid of that.
Exactly. And say if a fish swims at 68 miles per hour.
Because I don't know if we'll use them again. So I'm going to do that.
Okay, sounds good.
So our first one, if a fish
swims at 68 miles per hour, then it is a sailfish. So that's pretty much what we just did in the last one, too.
All right.
Those were right in order.
That wasn't too bad.
Okay, but now I'm looking, and I see, let's see. There's another 68. I'm looking at number 5 has a 68 miles per hour.
Okay.
But number 1 had a 68 miles per hour. And it's one conclusion and the other hypothesis. So I really need to start with 5 and then attach 1 at the end of that.
I'm going to put in parentheses. You're doing it 5, then 1.
Right.
Not 1 and 5.
Exactly.
Because how this one ends, this one begins.
Exactly.
And if you need to, let me just show for those that are maybe more of a visual. If I move this, I'm going to just move this one up and this one right below it. Notice the flow of it.
Yeah. Okay.
It's exactly what Mrs. Hoker is saying. So what would I say? Or what did I write?
A fish is the fastest species of fish.
Say that 10 times fast.
I could barely say it once.
I know. We made it
then,
hard. Write slower than Mrs. Hoker's talk.
Then it is a sailfish. And we could put other statements together as well if they go together.
Yeah.
I think that kind of gets our point across.
Yeah.
That you can move things around.
Exactly. And it says let's write some. It didn't say, it wasn't specific, so maybe at least 2, and then you can, if you want more, but you guys get the idea.
Okay. Now for this last example, we've got this looks a little more geometry-like to us.
It does.
We're not talking about fish right now. We're
Yes.
football. Okay, and it says we're going to use the diagram to give a reason for each true statement. So we know that these statements are true.
Okay.
We just need to come up with the reasons that they are
What
true.
kind of reasons can I use?
Well, that's a good question. We could use either definitions that we know. We could use any postulates that we've learned.
Okay.
We can use any accepted properties that we know.
Okay.
Just as long as it's something that we know for a fact, we can use it as a reason.
Okay.
Okay? And I'm going to mark our picture as we go too, because
Okay.
I want to make sure that we see all this. Since they give us some other information, the measure of angle 2 is 107. And then we know that 6 and 4 are congruent. So we're going to mark those with our little tick marks to make sure that we know that those two are congruent. And we know that 3 and 5. So I'm going to go ahead and put 2 congruence marks on those because they are congruent to each other, but not necessarily congruent to the ones that we have.
That makes sense.
Okay. So we know that the measure of angle 2 is 107. That was given to us. And I'm even going to write given beside it because that was in our given information.
So when they say give a reason, it could be just as simple as just the given?
That exactly.
Because
Given is a reason.
Well, because you have to be given something.
You have to know something to start.
Yeah, okay, that makes sense.
Okay. Now, the measure of angle 2 is 107. And if that's true, then we know the measure of angle 6 is 73. Now,
And that's the true statement.
we know
they're
it's a true
saying.
statement.
So
why
why
do we know that?
Okay, what I'm noticing is that the thing I'm thinking about is what do 2 and 6 have in, what's the relationship? And it's a pair of angles, and to me they fly in the same line, so they're a linear pair.
They are a
And
linear
pair add up to 180.
Perfect.
Or
if you check-
supplementary.
and if you check them, those two are supplementary.
Uh-huh.
Okay, so that linear pair, that would be our reason.
Okay.
Okay, the next one. If the measure of angle 6 is 73, then the measure of angle 4 is 73.
Okay, now I'm noticing because of your picture, I'm not even looking at the beginning, but I kind of did it just a minute ago. But when I can look at that picture, I notice because you labeled those congruent, well, if 6 is 73, angle 4 has to be the same measure. So the reason why is because those two angles are congruent.
Perfect.
And that's like the definition of congruent. So when you say use reasons, you said definition.
Yeah.
Would work.
Now, do we like writing out the words congruent angles every single time? We have symbols to use for these things.
Yeah.
So I want to just emphasize right here so that way we know the congruent symbol and congruent angles. So that's just a shortcut way to write that. And just so you guys know that would be perfectly okay for Mrs. Palermo or myself for you guys to be writing that on your papers.
Perfect.
We'll use those shortcuts. All right. Now, if the measure of angle 4 is 73, then the measure of angle 3 is 73.
So why
What are you
is that?
thinking here?
Well, I'm thinking again, like I was thinking earlier, what do those angles have in common? Well, angle 3 and angle 4 are both vertical angles. Mm-hmm. And we know vertical angles are congruent. So if they are congruent, they're going to have the same measure.
So we'll just say because they're vertical angles. Perfect. And then the next one says that if we know the measure of angle 3 is 73, then we know that the measure of angle 5 is 73. And why do we know that?
Well, again, based on the picture, angle 3 and angle 5 were given congruent, so they have to have the same measure. So they're congruent angles.
Congruent angles. Perfect. Okay. The next one says if the measure of angle 5 is 73, then the measure of angle 1 is 107.
Well, those are a linear pair.
You're catching on well.
And I've noticed in all of these, like I'm using similar reasons, mainly because we haven't gotten too in depth with some of the new ideas yet.
Sure.
As we progress, are we going to probably have more reasons?
We'll have different reasons that we can use too. But
Okay.
yeah, those are the main definitions and things that we've really
used.
looked at so far. Now, what about this next one? If the measure of angle 2 is 107, then the measure of angle 1 is 107. Why do you think that was going to be?
Well, I was noticing while we were going through these statements, like if I start at B, where that one ended, the next one I started with that. And then I kept doing that.
And what did we call that when we
the law of syllogism.
The law of syllogism.
So I could keep creating new true statements from the one prior, and basically in the end, if I combine all of those, I end up with that last statement. So would it be okay if I just said using the law of syllogism?
That's perfect.
That way I don't have to recreate all those statements.
Absolutely. It's just a way of saying that you're putting true conditional statements together to make a new true conditional statement.